Okay, you did a good job of seeing this. If this is equal to this, then of course this is true, right? And of that being what we have here, right? We're left with this and this. So there we have it. Psi is invertible because it's a fundamental set. In other words, the columns form a fundamental set. We've established that this thing then has to be, well, the Wronskian of this thing will then be non-zero. Okay? Meaning that the determinant of this matrix is non-zero. So that so there's variation of parameters. And it's a whole lot easier, okay? A whole lot easier to see this process from this premise than it is to work through the details of the variation of parameters formula for a second order equation, let's say. Okay? Not homogeneous second order equation. Now, of course, you got to be able to integrate, because this says that, okay, for example, then this means typically, your G of t function, depending on how many equations you have an n by n, a system of n equations. Okay? Then you're going to have to integrate all of these. But you can multiply psi inverse by this. And so this is u1 through un. It's u1 prime through un prime, right? Okay? And you're trying to find the u1 through the un. So you're going to have to integrate. Okay? So I'll say that, etc. To find the u1, u2, and so forth. And I should have put a un on the end of that, but I didn't have room. There's something kind of messed up at the edge of the board there. Okay? So that's understood. Make sense? That's a pretty simple process. If you understand that any system can be put into this form, understand what these matrices mean, and work out half a dozen problems. Okay?